Welcome back to Hardware Unboxed. Today we're going to be diving a little deeper into overclocking the new Nvidia GeForce RTX 2080 Ti, covering a whole range of things from how to overclock these cards to typical achievable clock speeds to performance and power consumption. If you've overclocked a GPU before, a lot of the things we go through in the guide section of this video will be pretty familiar to you, though depending on what GPU you last overclocked, there might be a few new things to note. And of course, if you're more interested in things like final overclock performance and clock speeds, you can just skip over the instructional section. To start off this video, I'll be going through our standard methodology for overclocking Nvidia graphics cards and specifically the RTX 2080 Ti. We'll also be showing you how Nvidia's new scanner API works and just how good their one-click overclocking can be comparing to a manual overclock, while also showing you how to do said manual overclock. And of course, the scanner API is new for these Turing cards. The card we're using today is the Founders Edition RTX 2080 Ti, which does come factory overclocked in some sense compared to base level board partner models. But that OC is, it's quite small at just 90 megahertz on the core and nothing on the memory. But the card we're using doesn't really matter. The steps you see here will apply to all RTX 2080 Ti cards. So the first thing we'll be doing is going through potentially the easiest method of overclocking your RTX 2080 Ti, and that's using Nvidia's new scanner API. One-click overclocking has been around for a while now, but this time Nvidia has built a framework for doing it rather than letting board partners create their own algorithms. And according to Nvidia, their framework is better tuned for their GPUs, more accurate and more reliable than any previous one-click methods. To use Nvidia Scanner, you'll need to grab one of the very latest versions of an overclocking utility. The two we tried were EVGA Precision X1 and MSI Afterburner, both in their beta versions. And for the scanner functionality, we found Afterburner to be more reliable. I had a few crash issues with the early version of Precision X1, which I assume will get fixed, whereas Afterburner seemed to work every time. It's a bit disappointing as Precision has a much nicer interface than Afterburner, but we'll get back to using Precision a bit later in the video. So after you've installed and opened Afterburner, you'll see a bunch of dials and sliders. Bit of a cluttered interface, but that's fine. What we're interested in is the small bar graph icon to the left of the core clock slider. At this stage, it's not necessary to touch anything else in the app. Simply click on the bar graph icon, then click OC Scanner, and then in that window, hit Scan. Now you can sit back and wait a while because the one-click overclock process takes around 15 to 20 minutes. What the scanner is doing is basically running a bunch of clock speed tests at a range of voltages to find the exact voltage frequency curve for your 2080 Ti model. It has its own test algorithm built in to stress the GPU with the ability to recover from any hangs or crashes if the GPU is being pushed a bit too hard. It's basically simulating what we'd do with a manual overclock, but doing it faster and potentially more accurately. Don't worry if the application hangs or your screen goes black temporarily during the process, that's normal. At the end, you'll be given an average overclock, but crucially, you'll get a full frequency curve, which potentially is a bit more efficient than a simple core frequency offset. And you can see at the lower end of the voltage curve, we're getting slightly higher overclocks than at the top. On average, we achieved plus 181 megahertz for our card, but the top end, our OC, is just around plus 150 megahertz. At this point, would recommend heading back into the Afterburner main application and cranking up the power and temperature limits to the maximum. We've never benchmarked a card, even a last generation Pascal card, that didn't like having these limits raised all the way. So with the 2080 Ti, it just makes sense to crank it up. This will allow Nvidia's GPU boost algorithm to push as high as possible on top of the frequency curve we've already set, potentially going beyond the old limit. One thing to note here is we have just set the power and temperature limit after running Nvidia Scanner. Nvidia says the scanner only modifies the core clock, so if you change the power and temperature limits beforehand, the scanner might find different and potentially higher core clocks. However, in our experience, we actually achieved lower clocks in the scanner setting the power limit beforehand, so we'd recommend cranking it up after the scanner is complete. The other obvious limitation is the lack of memory clock gains. Nvidia Scanner only handles the GPU core and doesn't touch memory. So if you're after that simple one-click overclock solution, you'll be missing out on any gains you'd get from tweaking memory. Core overclocking is much more important for getting performance gains, but a boost to memory can help out in some situations. So we've got the Scanner OC results now in the bag. Let's show you how to perform a manual overclock, and after that, we'll compare the manual overclock to the scanner results. For this, we're switching to EVGA Precision X1 because it has a much nicer and more intuitive interface. For manual overclock, we want to start from a decent point. So again, we're going to crank the power limit and temperature limit to the maximum. We're also going to scroll the bottom section across to the temp tuner and adjust the curve so we're getting the maximum clock speed at all possible temperatures. For our reference card, this isn't a big deal as we're not reaching up to those highest temperatures, but if you are running above 84 degrees Celsius, you'll want to adjust this curve for maximum performance. From here, it's all about adjusting the two main sliders for memory and core frequency. The basic steps are, we want to increase each value by a reasonable amount, apply the overclock, then validate it in a program like 3D Mark to ensure we're not getting crashes at those settings. The amount you increase the values is up to you, but note that you're not going to damage your card by choosing a value that's too high. Instead, you'll just crash your system and have to reset it, so that's no big deal. For the 2080 Ti, we started with around a plus 150 MHz offset on the core and plus 500 on the memory. Those are fairly conservative figures for the card. That worked in 3D Mark, so we pushed the core up to plus 200 and memory up to plus 650. If you want to play it a bit more safe, we'd recommend only changing one of those values per test run, but the more you become familiar with the process, the more you can adjust at once. With plus 200 on the core, our 2080 Ti crashed in 3D Mark, so now it's a process of finding the exact limit. We stepped down in 10 MHz increments, eventually discovering that plus 180 was unstable, but plus 170 was perfectly fine. From here, we can try to push up the memory even further using a similar sort of process, and for our model we settled on plus 700 being that sweet spot. So our final stable overclock for this card was plus 170 MHz on the core and plus 700 MHz on the memory, and that's a fairly typical figure going on what we've seen from others. Note that if you have a non-FE or non-factory OC card, the core offset you'll need will be higher as you're coming from a lower starting point. Once you find what you think are stable overclocks, it's always a good idea to validate them further in a game running for several hours, something very GPU intensive. While 3D Mark's time spy gives a good indication of whether a card will work at a certain frequency, sometimes it will only crash under a longer test, so it's good to test both. A quick note on voltage. Nvidia's Turing cards are voltage locked. In other words, Nvidia does not expose proper voltage controls to the user like you might get with overclocking a CPU on a motherboard. Instead, we have a voltage slider, but it's not really an offset. What it theoretically does is raise the voltage limit by a few steps, but still within what Nvidia deems safe. And that comes at the expense of lifespan. Nvidia claims you should get 5 years out of stock voltage and just 1 year with the voltage limit raised slightly, so keep that in mind. In practice, raising the voltage slider did absolutely nothing for our overclock, where plus 170 MHz on the core was stable under a 0 voltage figure, plus 180 MHz with a maximum 100 voltage figure still wasn't stable. You might have a different experience, but it did absolutely nothing for us. So on a pure clock offset basis, the scanner OC coming in at around plus 150 MHz, the top voltage range is lower than our plus 170 MHz manual overclock. Plus, of course, with manual overclocking, we increased the memory frequency as well. This indicates manual overclocking is still the way to go, and you can see this is the case when looking at our Shadow of the Tomb Raider results. Here the scanner provided a 7% performance improvement over the FE clocks, whereas our manual overclock produced a 12% improvement. However, the scanner does not overclock the memory, and for those looking for a quick overclock procedure, one easy trick might be to use a fairly conservative memory overclock for simplicity's sake, something like plus 600 MHz. Going with that changes the results and makes the scanner plus memory overclock 11% faster than the FE clocks, but again, the full manual overclock provides a slightly better result, a further 1.5 percentage points. So we've now shown that our manual overclock is very slightly superior to the results with the OC scanner. Now let's take a look at a handful of games to see how the overclock compares to both stock and Founders Edition performance. In Shadow of the Tomb Raider running at 4K with the maximum quality settings and SMAA T2X, we saw overclocking provide 16% more performance than the standard clocks for the 2080 Ti and 12% more than the Founders Edition clocks. That's not a bad result, certainly worth doing, but you're not going to have your socks blown off by the overclocking headroom available in this card, at least especially compared from the Founders Edition. In Assassin's Creed Origins at 4K ultra high preset, the margins are a little narrower, 11% performance increase over the default clocks and 9% over the Founders Edition. In Far Cry 5, we're looking at 16% over the default and 12% over the Founders Edition again, same results as Shadow of the Tomb Raider. In Middle-earth Shadow of War, there was a 14% improvement over default and 11% over Founders Edition. And finally, in Batman Arkham Knight, 12% over default and 9% over Founders Edition. So from those 5 games, we achieved a performance improvement of 14% on average compared to the stock clocks and 10% improvement compared to the Founders Edition clocks. We're pretty much running into a power limit here. Looking at the design of the power delivery system on the FE cards, there might be a bit more headroom available if Nvidia properly unlocked voltage controls, but this is around as good as we're getting from what we can configure at the moment. Of course, we should note that Nvidia do appear to be binning their 2080 Ti GPUs. Graphics cards shipped with stock clocks use one SKU, while those with factory OCs use a different, potentially bin SKU. This means that factory OC cards should overclock better than their non-OC alternatives. So while we are saying here that we achieved a 14% performance improvement compared to default clocks, the reality is some cards shipped at default clocks won't OC as well. In terms of temperatures and fan speeds, what Steve found in his initial review of the 2080 Ti is spot on in what I achieved on my test bench. Core temperatures increased from 76 degrees Celsius under load with the Founders Edition clocks to 81 degrees when overclocked. That's a bit below the card's native 84 degrees temperature limit and well below the increased 88 degrees limit. So it's pretty clear that that's not going to be a limiting factor for performance. Fan speeds as well, 2060 RPM with the FE clocks, 2290 when overclocked using the default auto fan speed. So a slight increase there, but really no difference to the sound profile. The card is pretty quiet while overclocked. Also, of course, both the noise output and temperature will be different with board partner models. And if you're wondering about power consumption, well, there wasn't a lot of difference in load power draw between the default and Founders Edition clocks, though that shouldn't be a huge surprise considering the FE clocks are only about 3% faster. But when overclocked, power draw increases by around 14% on average compared to the FE clocks, so a 14% increase in consumption for 10% more performance. That's a pretty typical result. If you're wondering about the actual clock speeds I achieved, I was averaging around 1680 MHz in Shadow of the Tomb Raider with the stock clocks, 1770 MHz with the FE clocks, and around 1980 MHz when overclocked with a peak around 2100 MHz. I also tried overclocking with the fan set to 100%, which dropped temperatures by 20 degrees Celsius, but that only got around 30 to 50 megahertz more out of the card, and that was purely from GPU boost. Changing the clock offset resulted in instability. Running the fans at 100% resulted in less than a 1% boost to performance over our manual overclock with the fans on auto, and of course the card is much louder at 100%, so it's really not worth it, at least with our sample. However, those who install liquid coolers on the card might be able to eke out a bit of extra performance, but not all that much. So that just about wraps up this look into 2080 Ti overclocking. With the cards we have on hand, there is some extra performance to squeeze out, and it will be interesting to see if anything more can be gained from additional tweaks, particularly special mods to increase voltage. For regular users though, around a 10% increase over FE cards is expected. And of course we showed FE card results in our previous benchmark video, so if you're interested what extra performance you'll be able to get with overclocking, simply apply sort of a 10% increase on average to those game results. Manual overclocking is still the go-to option, though Nvidia's scanner API is quite handy for those that don't want the pain of manual tweaking. If you're interested in our ongoing Nvidia RTX coverage, subscribe to get that content in your inbox, and be sure to hit the bell icon too. Consider supporting us on Patreon to chat directly with us about RTX cards in our exclusive Discord chat, or really about anything else, in particular Steve's love of Nando's. I'll catch you next time.